Today's lesson is on the sum and difference formulas. We're going to be looking at the sum and difference formulas for cosine, for sine, and for tangent. So, the sum and difference formulas for cosine. Here's what I want you to see about these formulas. We've got the cosine of alpha plus beta. This is why they're called the sum and difference formulas, because we're looking at the cosine of the sum of two angles. And the formula for the cosine of the sum of two angles, if you will look at the cosine, C stands for cosine, so we're going to do the cosine of alpha times the cosine of beta. O is going to help us to remember that we always take the opposite sign right here, so minus, and S is going to stand for the sine, so we're going to do then the sine of alpha, the sine of beta. Now that's not, and I wrote that way too big so you can't even see it all. Alright, there it is. I'll write the next one smaller. The cosine of the difference of two angles, we can use the same type of little pattern. The C stands for cosine, so cosine of alpha, cosine of beta. O stands for opposite sign, so instead of a minus we're going to put a plus, and S standing for sine, so that's the sine of alpha and the sine of beta. See if I can slide it all in there. Okay, now if you can just remember that little formula, it's not mathematical, but it's a little method for us to remember that when we're doing the cosine of the sum or difference of two angles, we do the cosine times the cosine, that's the C. We always take the opposite sign, and then we do the sine times the sine. Now what this is going to help us do is find exact values of the sum, or exact values of an angle that we may not know right off the top of our head and from our unit circle what its cosine is. So let's look at this first example. Okay, we've got the cosine of 105 degrees. Well, the cosine of 105 degrees, off the top of my head, I really don't know what it is. It's not one of the ones that I've memorized from my unit circle. However, if I can break it down into two angles that are on my unit circle, and you can see from the PowerPoint here that we chose to break it down into 60 degrees plus 45 degrees, 60 degrees plus 45 degrees giving me 105. Now that is not the only way you can break it down. We could have done other things, and maybe during class today we will discuss some of those other things. But 60 plus 45 is definitely 105. Now I can use my sum formula for the cosine to rewrite this and to be able to find out what the cosine of 105 is, because I know that the C means cosine, so cosine of 60 times the cosine of 45. O stands for the opposite sign, so since this was plus, I'm going to do minus. And then we have S standing for sine, so the sine of 45 times the sine of 60. And I'm going to run off the page. I'm writing too big today. And now we can, from our unit circle, we can tell what the cosine of 60 is, that's 1/2, times the cosine of 45, which is square root of 2 divided by 2, minus the sine of 45. And I did mine backwards from the way that I did it in the PowerPoint. I apologize for doing that. But the sine of 45 is the square root of 2 over 2, and the sine of 60 is the square root of 3 over 2. Again, commutative property here says I can do that either way. Then when I multiply these together, I'm going to get the square root of 2 over 4 minus the square root of 6 over 4. And since these both have the same denominator, I can go ahead and add them together. And so that gives me the cosine of 105. Let me scoot up just a touch. So I've got the cosine of 105 degrees is equal to the square root of 2 minus the square root of 6, all divided by 4. Okay, easy enough. It's just a matter of taking our angle breaking it down into two angles that are on our unit circle, and using our formula to find the exact value. Okay, so let's look quickly at the sum and difference formulas, and I'm going to pull this up a little bit so I have a little bit more room to write. And I hope you'll still be able to see that without any difficulty. The sum and difference formulas for the sine. Okay, now the sum and difference formulas for the sine are the sine of alpha plus beta, make sure I'm on the screen, is equal to, now these are different than the cosine. Remember, cosine was cosine, cosine, opposite sine, sine, sine. So what we have to remember here with the sine is that we're going to do the sine of one angle and the cosine of the other. So the sine of alpha times the cosine of beta. Then we're going to keep the same sign, so this is a plus, sine is the same sign, and then we're going to do the sine and cosine of the other two angles. So since I did the sine of alpha here, I'm doing the cosine of alpha here. I did the cosine of beta here, so I'm going to do the sine of beta here. Okay, that's the pattern. And if you're doing the difference formula, the pattern is the same. We're going to do the sine of one angle times the cosine of the other. Same sign, so it's minus. And then we're going to do the cosine of the first angle and the sine of the second. And that's our formula. Now, what we're going to do next, and this is one of the problems that that gets students a little bit flustered sometimes because of the fact that we're using radians. It says find the exact value for the sine of negative pi over 12. First of all, it's negative, and second of all, it is in radians. Now the hardest part here is trying to figure out what can I add together to get negative pi over 12. Well, you've got lots of choices. If my common denominator is 12, I know that 3 and 4 have their common denominator would be 12. And if I take pi over 4, okay, and I'm going to come right up here and I'm going to change it to a denominator of 12. Well, 4 goes into 12 3 times, and 3 times 1 is 3, so 3 pi over 12 is the same as pi over 4. And I'm going to change pi over 3, oh, I didn't put my pi here, I'm sorry, pi over 3 to a denominator of 12. 3 goes into 12 4 times, and 4 times 1 is 4, so that's 4 pi. And if I subtract 3 pi over 12 minus 4 pi over 12, that gives me negative 1 pi over 12. So that's where I came up with my pi over 4 minus pi over 3, because when I do subtract them, I get negative pi over 12. And for most students, I find that that's the most difficult part, is trying to figure out what to put in these parentheses so that you get negative pi over 12. Once you've figured that out, then you're just going to use the pattern. So the sine of pi over 4 times the cosine of pi over 3, same sign, minus the cosine of pi over 4 times the sine of pi over 3. Okay. Now all I have to do is go to my unit circle and say the sine of pi over 4 is the square root of 2 over 2 times the cosine of pi over 3, which is 1/2, minus the cosine of pi over 4, which is the square root of 2 over 2, times the sine of pi over 3, which is the square root of 3 over 2. Then I can just multiply. The square root of 2 times 1 is the square root of 2. 2 times 2 is 4. Minus the square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4. And then I could write this as the the sine of negative pi over 12 is equal to the square root of 2 minus the square root of 6. Scoot up just a touch. And we're going to keep our denominator of 4. Okay, so that is how we use the sum and difference formulas for the sine to find exact values. Okay, the next thing that we're going to do is look at the sum and difference for tangent. And you can see on the PowerPoint here that you have the sum and difference formula for your tangent. Then what I want to do is take just a minute to kind of show you the pattern here so that you can see it, because I do like you to learn the patterns as opposed to trying to memorize a whole lot of letters and numbers and things. So if I have the tangent of alpha plus beta, the first thing I'm going to do is I'm going to remember that a tangent is always going to be a quotient. My sum and difference formula for a tangent is always going to be a quotient. And I'm always going to take the tangent of alpha plus the tangent of beta. So if this is tangent of alpha plus beta, you're going to keep the same sign, and you're going to do the tangent of the first angle, keep the same sign, plus the tangent of the second angle. And then on the bottom, it's always going to be 1, and then we're always going to do the opposite sign, and then we're going to multiply the tangent of alpha times the tangent of beta. And when you're doing the tangent of alpha minus beta, we're going to do the same thing. It's going to be always a quotient. On the top, it's going to be the tangent of alpha, keep the same sign, minus the tangent of beta. And then on the bottom, it's always going to be 1, opposite sign, tangent alpha times tangent beta. Okay, so that's the formula for the sum and difference of tangents. Okay, now what I want you to do is to try this problem, find the exact value of the tangent of 195. I'd like for you to pause this video, try this, and then come back and we'll work it together. All right, so let's look at the tangent of 195. The tangent of 195 degrees. All right, the first thing that I know is that that's not on the unit circle, so I'm going to need to break this up into the tangent of two angles that are on the unit circle. So I'm going to pick 150 degrees plus 45 degrees. Okay, the tangent of 150 plus 145 is the tangent of 95. So the next thing that I'm going to do here is I'm going to rewrite my tangent of 195 using 150 and 145 and my tangent formula for the sum of the tangent. So I'm going to say the tangent of 150 plus the tangent of 45, because for the numerator I'm going to use the same sign. And then I'm going to say on the bottom 1 minus, because it's always the opposite, the tangent of 150 times the tangent of 45. So now the next thing that I need to do is go to my unit circle and say, well, what is the tangent of 150? The tangent of 150 is the square root of 3 over 3 plus the tangent of 45, which is 1, divided by 1 minus the tangent of 150, which is the square root of 3 over 3, times the tangent of 45, which is 1. Now this simplifies to the square root of 3 over 3 plus 1, but I'm going to write the 1 with a denominator of 3 so that I can add those in just a moment. And then this 1 I'm going to write as 3 over 3 because I'm going to be subtracting the square root of 3 over 3, because the square root of 3 over 3 times 1 is just the square root of 3 over 3. Now adding these together, I'm going to add my numerators, and I'm going to say the square root of 3 plus 3 over 3. Add my numerators, keep my denominator, divided by 3 minus the square root of 3 over 3. Now hopefully you will remember from our discussions previous to this that when we're dividing a complex fraction like this, that my denominators are going to cancel. If you don't remember that or you don't know why that happens, then we're going to use our definition of division and say keep the numerator, change this division to multiplication, and take the reciprocal of the denominator, and that will show you why those 3's cancel. So I end up now with the tangent of 195 is the square root of 3 plus 3 over 3 minus the square root of 3. Now there's nothing wrong with this answer. is the correct answer. However, on standardized testing, they're going to always rationalize the denominator. To rationalize the denominator, when you have a binomial radical in the bottom, you always use the conjugate, which means we're going to have the same two terms, but one is going to have a plus sign and one's going to have a minus. And whatever I do to the bottom, I have to do to the top, because remember, I can only multiply by 1 and not change the value, and that's just a big ugly way to write 1. So now we're going to multiply these together. These are two binomials, so if you want to put parentheses here to help you, that would be great. And then you're going to do 3 square roots of 3. Then you're going to do 3. Then you're going to do 9. And then you're going to do 3 square roots of 3. And then in the denominator, we're going to get 9, 3 square roots of 3, minus 3 square roots of 3, and then minus 3. Now, because we're multiplying conjugates in the denominator, these two in the middle will always cancel out, so that we will get here 6 square roots of 3 plus 12, because we're adding 3 square roots of 3 and 3 square roots of 3 to get 6 square roots of 3. 3 plus 9 is 12, over 9 minus 3, which is 6. If you notice, if you notice in the denominator, we have a 6, and in the numerator, we have 6 square roots of 3 plus 12, which has a common factor of 6. So I'm going to factor out that common factor of 6. Keep scooting too far down and you can't see what's going on. Common factor of 6 will cancel, and now I get the tangent of 195 degrees is equal to the square root of 3 plus 2, or in some instances they might write 2 plus the square root of 3.